Welcome to the lecture series of linear IC applications. Today we are going to start the topic called operational amplifier, which is abbreviated as op-amp. So let us see the basic features of operational amplifier, what purpose it has designed and what are its stages. As we know that amplifier is an electronic device which is used to increase the strength of weak signal to a strong signal without changing its original shape. That is called as amplifier. Now we have one more word associated with amplifier, that is operational amplifier. Why the name operational amplifier is because basically this amplifier is designed to perform certain mathematical operations such as addition, subtraction, multiplication, division, etc. Therefore, it is called as operational amplifier. This operational amplifier is a quite versatile device which is also available in a single IC package. It is used to amplify the DC signals as well as AC input signal. Before starting this operational amplifier, what are the types of amplifier we have studied? They were not able to amplify the DC signal. We have seen only the amplifiers which are capable of amplifying the AC input signal given to it. That's why it is called as a versatile device. Its frequency range, amplification frequency range starts from 0 Hz to several gigahertz. It is a direct coupled high gain amplifier. So now let us see the block diagram of operational amplifier. We know that the operational amplifier is a multi-terminal device. That means more than one input is provided to it and one output will be there from the op-amp. So now the two inputs which we are giving to the operational amplifier is a non-inverting input and inverting input. What is that we will see? The first stage, which is called as input stage, it is nothing but a dual input balanced output differential amplifier. Most of the voltage gain will get provided by this first stage of amplifier, and what the circuit consists of is in this input stage is a dual input balanced output differential amplifier. We know the meaning of amplifier. Now we will see what is differential amplifier. When we give two inputs to the amplifier, it has to amplify the difference between those two signals. That is called as differential amplifier. And then what do you mean by dual input and balanced output? As we know that differential amplifier we consist of two transistors. Now when the inputs are applied to both the transistors base terminal, we are calling it as dual input. If only one input is provided to any one of the transistor, we call it as a single input. And what do you mean by balanced output is, as we know that there are two transistors connected, and when we are going to take the output with respect to each other's transistors collector terminal, we call it as balanced output. So the very first stage in case of op-amp which we are using is dual input balanced output differential amplifier, and the enough amount of voltage gain is provided by this input stage. And generally the output of this first stage is provided to the intermediate stage of your op-amp, which is again nothing but a dual input but here unbalanced output differential amplifier. That's the reason you can see here I have shown with the arrow two arrows. That means here output I have taken from both the transistors. So I'm just showing that there are two outputs are coming, which is input for the intermediate stage, and as you can see it's a dual input. That means both the transistors of differential amplifier will get input from this circuit, and as it is unbalanced output, the output is taken only from one of the collectors terminal from the transistor, and therefore with respect to ground, and therefore only one output I have shown over here, and that output is given as an input to the level shifter. Then what is the need of level shifter? We know that in case of differential amplifiers which we are discussed here, they are a direct coupled amplifiers, and because of that there is a possibility of getting the DC level, getting the DC level should be is shifted either to up or down. So now this shifting of DC level has to get compensated. That means it has to come to its zeroth level. Therefore, we are going to use a level shifter over here. That level shifter is nothing but a emitter follower with current which uses a constant current source. Then the output of the level shifter is given to the output stage, which is nothing but a complementary symmetry amplifier. The use of this complementary symmetry amplifier is to produce to have a high output voltage swing, and it also increases the current supplying capability of your op amp. And if we are designing a well op amp, then it is always possible to get a very low output resistance from the circuit. So this is a brief about the block diagram of operational amplifier. Now let us see what is the symbol of this op amp. This is the symbol or schematic symbol of your op amp, which consists of two inputs and one output. Now this two input terminals, the terminal with negative sign is called as an inverting amplifier, inverting input, and the positive terminal is called as non-inverting terminal, and V0 is your output. Then why this is called as inverting and non-inverting, that we have to see. Here, when you are applying any AC signal or DC voltage to these inputs, then it produces output. When let us say we are applying input, AC input or any DC voltage, okay, to this inverting terminal of the op amp, the output which it produces is out of phase. That means the output which we are getting when we apply input to this inverting terminal, we will get the signal 180 degree out of phase. Therefore, this terminal is called as inverting terminal. That means whenever we are going to give a AC signal or DC voltage to this input, it will give a 180 degree out of phase, or that is nothing but opposite polarity at the output. Therefore, it is called as inverting. And coming to the non-inverting, when you apply AC input or DC voltage to this particular input, it will produce an output which is in phase, with the input, or same polarity. Therefore, this is called as non-inverting terminal. Okay, so if you this is, let us say, V1, this is V2, and this is your V0. Now let's see this op amp. This is a symbolic representation of a op amp, right? So now we can have this op amp either in an open loop op amp or a closed loop op amp. So what do we mean by open loop and what do we mean by closed loop of op amp, and what are their applications, that we have to see. Now the very simplest way to use your op amp is your open loop mode. That means when you are applying the signals V1 and V2 at the inverting and non-inverting terminals, and we know that the gain of the op amp is infinite. Therefore, whatever the output voltage will be there, whatever the output voltage comes, that output voltage will be either at positive VSAT or it may be a negative VSAT. That means when you have V1 is greater than V2, your output will be a minus a VSAT, and when you have V1 less than V2, then your output voltage will be plus VSAT.